We'll begin section 10.5 in this video, and 10.5 is all about applications using quadratic equations. The earlier sections were all about solving quadratics, so let's look at some applications now. A lot of the problems in this section are related to geometry, specifically area of a rectangle and area of a triangle, and then we'll also look at the Pythagorean theorem a little bit later. Okay, so the area of any rectangle is where you take length times width. The area of any triangle is where you take 1/2 base times height. Problem 17, it says the width of a rectangle is 6 feet less than its height, than its length, excuse me. If the area of the rectangle is 112 square feet, find its length and width. Okay, so I want to start off with the formula there for area of a rectangle, length times width. The area of this rectangle is 112 square feet. Now, we don't know the width. We don't know the length either, right? But we are told some information here that the width of the rectangle is 6 feet less than its length. Okay, so whatever the length is, 6 feet less than that would give me the width. That means to get W is equal to L minus 6. So I'm using this formula here, area equals length times width, but the width, I'll write L minus W. That way everything is in terms of L, and I don't have L and W floating around. Okay, so I would then solve for L. I'm going to distribute L. You get L squared minus 6L. Also, let me subtract 112 from both sides. And I've created this quadratic equation. By the way, when you're setting up the problems in this section, there should be no mystery as far as what kind of equation you should be working with. Okay, we're working with applications of quadratics. Okay, so if you get, like any other story problem, you got to read the problem, figure out what they're talking about, and form an equation that represents the situation. But keep in mind that we're talking about a quadratic here, so we should have a quadratic representing the situation there. So then I would solve this quadratic. Okay, this one's going to factor nicely. L minus 14 times L plus 8 would give me the line right above here. Okay, and then when I set these factors equal to 0, L equals 14, or L is equal to negative 8. Now L is the length of this rectangle, which I know can't be a negative. We're talking about distance. So throw away the negative 8 there. That doesn't make any sense. Looks like the length of this rectangle is 14 feet. The width would be 6 feet less than that. So the width would be 8 feet. Okay. Here's another problem. Problem 18, the length of a rectangle is 3 inches more than twice its width. If the area of the rectangle is 75 square inches, find the length and the width. Give the answers to the nearest tenth of an inch if there's any rounding. Okay. So I've got a rectangle here. This rectangle has an area of 75 square inches. Now, by them telling me that information, it suggests that I'd want to be doing something with area of a rectangle. Okay, area equals length times width. Now, we don't know L and W. That's what we're supposed to find here. But it says the length of the rectangle is 3 inches more than twice the width. Okay, so whatever the width is, the length, L, is going to be twice that, but then 3 inches more than twice that. Okay, or 2W plus 3 would be the expression representing the length there. So I'm writing this in terms of W, okay, and I would need to then solve for W. Let's distribute W here. You got 2W squared plus 3W. I'm also going to get everything onto one side. Minus 75, that's all equal to 0. Okay, this equation is not going to factor nicely, so we would want to use the quadratic formula next. We want the opposite of b, that's negative 3 plus or minus the square root of b squared. 3 squared is 9, minus 4 times A is 2, times C is negative 75, and this is all over 2A, 2 times 2 is 4. So then I would go to the calculator, and all right, if you take 4 times 2 times 75, that should be 600. 9 minus a negative means that you're adding 600 to 9, so 609 would be the discriminant. So then if we go to the calculator, okay, I got, just use the graphing calculator is the one I grabbed here. What is it? We got negative 3 plus the square root of 609, enter, divided by 4. 5.4, if we go nearest one digit, okay, and then type in negative 3 minus the square root of 609 divided by 4 is negative 6.9. Okay, so that's what I got here, these two values. Of course, W can't be a negative, right? You're talking about the width of a rectangle. And so throw away the negative 6.9. That doesn't make sense for what we're doing. The width is 5.4 inches. The length is twice that number, but 3 inches more. So 2 times 5.4 would be 10.8. Add 3, that'd be 13.8. Okay, now that's an approximation since we were rounding 5, the width there. It's not 5.4 and then it just stops, right? It's what I had here, 5.419448, it keeps going. So be sure that you're using the approximation sign, if there's any rounding there. Of course, make sure that the units are also provided, whatever the units are in the problem. Okay, problem 19. The height of a triangle is 1 foot less than 3 times its base. If the area of the triangle is 22 square feet, find the base and the height of the triangle. Okay, so the area of any triangle is 1/2 base times height. And of course, so I'd want to be using that formula. The area of this triangle is 22 square feet. So 22 equals 1/2 base times height. Now the height is 1 foot less than 3 times the base. Okay, so whatever the base is, I want 3 times that, but then 1 foot less than that, or 3b minus 1 would give me the height. We've got everything in terms of b here, so we'll now need to solve this equation for b. If I multiply both sides by 2, that'll get rid of the fraction there. And then distribute b, we got 3b squared minus b, and then if I get everything onto one side here, minus 44, that's all equal to 0. This equation will factor as 3b plus 11 times b minus 4. Now if I'm not seeing that right away, I'm using the quadratic formula, right? Give it a couple of seconds. If you don't easily see the factors, use the quadratic formula. So anyway, this one did factor. Here it is. 3b plus 11 equals 0 means that b would be negative 11 thirds. B minus 4 equals 0 means that b is 4. B is the base of the triangle. That can't be a negative number. That makes no sense. So throw away the negative there. And it looks like the base of this triangle would be 4 feet. And the height would be 3 times that number minus 1. Okay, so 3 times 4 is 12, minus 1 is 11 feet. Here's another one, problem 20. The length of a rectangular swimming pool is 2 meters more than twice its width. Find the pool is surrounded by a concrete deck that is 2 meters wide. And if the area of the surface of the pool and the deck is 180 square meters, find the dimensions of the pool. All right, so I've drawn a picture. We have this rectangular pool, and then there's a deck wrapping around the pool that is 2 meters wide. Okay, so the distance from the edge of the pool to the edge of the deck would be 2 meters then on all four sides. Okay, now the pool, it says the length of the pool is 2 meters more than twice the width. So here's the width, here's the length. Now I'm supposed to find the length and the width of the pool in the problem. Okay, the length is 2 meters more than twice the width. Okay, so twice the width would be 2W, 2 meters more than that. 2W plus 2 would be the length of the pool. The area of the surface of the pool and the deck is 180 square meters. Okay, so that means that the area of this big rectangle here, the bigger one, is 180 square meters. Well, because it's a rectangle, I want length times width. What is the length of the deck? Now, the length of the pool is 2W plus 2. I'm not asking for that. I want to know this measurement here, that is the length of the deck. Well, it's going to be 2W plus 6, right? Because I've got 2W plus 2 plus another 2 is going to give me 2W plus 6. How about the width of the deck? The width of the pool is W. That's not what I'm asking for. I'm asking for the width of the deck. That'd be this measurement here. So I'm going to have to take W and then plus 2 meters up at the top and 2 meters at the bottom of this picture. So that'd be W plus 4 is this measurement here. That is the width of the deck. Okay, and so this equation would be my setup equation then for the problem. And now I would want to solve for W. Once I have W, I'll know the width of the pool, and whatever number that is, then I can multiply by 2 and add 2 to get the length of the pool, and I'll know the dimensions. So let's solve for W here. I want to FOIL out the right side. 2W times W is 2W squared. The outer and the inner terms, we're looking at 8W plus 6W is 14W. And then the last term, 6 times 4 is 24. Okay, if you subtract 180 from both sides, 24 minus 180 is negative 156. We can make the numbers nicer than what they currently are by dividing both sides by 2. Okay, so that's what I've done on the next line. Divide each of these three terms here by 2. And so we get W squared plus 7W minus 78 all equal to 0. This is going to factor nicely as W plus 13 times W minus 6. Again, if you're not seeing that, easily use the quadratic formula. Okay, W plus 13 equals 0 means that W is equal to negative 13. W minus 6 equals 0 means that W is 6. W is the width of the pool. That can't be a negative. Throw away that number. Okay, and so it looks like the width of the pool is 6 meters. And the length of the pool would be twice that, but then 2 meters more. So, okay, 2 times 6 is 12, plus 2 is 14 meters would be the length of the pool then.